Hi, everyone, and thanks for joining us today. I'll be talking about the challenges of the machine learning life cycle. So a little bit about myself. My name is Diego Oppenheimer, and I'm the CEO and founder of an organization called Algorithmia. We're a Seattle-based startup. Before actually working at Algorithmia, I built some of the largest data analysis products over at Microsoft, including Excel, Power Pivot, SQL Server. So if you remember anything from today's talk, I just want you to remember this slide, which is production machine learning is very different than actual machine learning. So there's a bunch of considerations that need to go into what it actually takes to bring ML to life inside an organization to start actually getting ROI out of your machine learning process. And how do we operate applications that are powered by machine learning? So a little bit about what the problem is. So today, productionizing ML is actually the biggest barrier into actually realizing value around machine learning projects. And this has actually been brought out by a bunch of research in Gartner, but it's number one thing, which is how do we actually take our machine learning models, put them in production, and actually allow them to drive our business in a way that is governed, secure, auditable, scalable. And so that's a lot of what we're going to be talking about today, and kind of some of the challenges that are presented and potentially how to actually be able to address those. So probably no news to anybody, but there's a massive explosion in demand for AI. So we're seeing many organizations, almost every organization that we talk to is actually starting or at least going down a path of how do we actually bring AI to life. But one of the things that is really happening is that only 10% of these organizations have actually deployed any ML solution into production. And so when you start digging into what the problems are here and why that is the case, massive demand, clear identification of why this is going to be useful to the organization, but very little to show for, even though there's some large investments. So let's think about what the actual machine learning lifecycle looks like. So for one, it's actually one of the fastest moving software paces that actually exists in an organization. There is a bunch of tooling in terms of data acquisition, model training, model development that needs to happen. But then once you actually have a model and a serialized model that can actually go into production, you need to actually start thinking about the deployment and operations of that. And so this includes actually deploying the model, managing versions, connecting to data services, registering those pipelines, actually operating the model, which means monitoring, reporting, being able to actually dive into when things go wrong, managing the infrastructure around this. And then obviously, especially in large organizations and when they're in regulated industries, how do you actually do the governance, security, and operations for all of this? So one of the big barriers of actually going into production is actually that you need to actually be able to pass kind of security checks around data, network, model security, InfoSec compliance, and in some cases, regulatory compliance. So we talk about these three concentric circles that are continuously iterating. And this is where the new machine learning lifecycle comes from. So how do I get that model trained? How do I get it deployed? How am I operating it? When something goes wrong, how can I go back to training, collect new data, rebuild it, deploy, etc. And this cycle is extremely fast. So when we start looking at the challenges inside model operations and management, there's a compounding effect around different categories. So for one, the stuck in the lab problem. This is, I have a bunch of data scientists. They've actually built out some really interesting machine learning models that can be applied to the business, and there's no knowledge or ability to actually get it out into production. Disconnected teams. So this is, in a lot of cases, we call it the throw over the wall problem. I built a model, I have maybe a container, I throw it over the wall to a software engineering team that is actually going to productionize it. That cycle is very broken, and in a lot of cases creates a lot of problems. We talk about technology mismatch. So this is, what technologies are being used for the applications, how are those applications running, what technologies are being used from a training perspective. When I'm building pipelines, how I start mixing technology between like R models and Python models, CPU models, GPU-based models. The stakeholder buy-in is around how actual organizations are actually championing these efforts. So in a lot of cases, for something to actually make it through, you need actual champions in the organization who see the value for the business, will actually break down barriers and actually hold on their name to actually say, hey, this is a worth initiative that we want to get to. And then finally, hidden technical debt. As I'm actually building out machine learning applications, as I'm actually building out new technologies and bringing them to the organization, how I'm actually taking care of maintenance, operations, new dependencies, and this is growing. So every single one of these components is actually magnifying the problem around creating an inefficient machine learning lifecycle. So what's the consequences of that? Well, 50% of machine learning projects actually never see the light of day. And in some cases, it takes up to 18 months from lab to actual production. And in most cases, this has already decayed the entire value of the machine learning model if it's actually taking that long to be able to productionize. So why is this actually happening, and what's kind of actually happening? This is showcased. Well, the fact is that it's an evolving ecosystem, and it's a very iterative system. So if we think about kind of data science teams as software teams, they're the fastest moving software team usually in an organization. Their ability that they need to iterate, retrain, rebuild, redeploy is much faster than what we commonly see in software development. And so when we start thinking about, okay, how do we get to speed in traditional software development and the DevOps tooling that we've brought about it, now, okay, well, what if we need to do that 10 times faster? What if we need to do that 100 times faster? So actually having the processes in place, the continuous deployment, continuous integration, and scalability of that becomes even more important for this to actually be able to be successful. So let's get a little bit tactical about what some of the challenges are. So what you usually see is that deploying ML models today is actually economically challenging. And this is around 5 different factors. Due to a lack of process, due to the wrong incentives, due in some cases to the wrong teams, due to the wrong technology, and due to the wrong proper champions. So let's go dive a little bit deeper into those. So when we talk about lack of process, a lot of these cases, it's actually really easy to get a POC funded and experiments running. I have a really smart data science team. They have some data. They want to build it out. They build something really small in a test and experiment. And they say, hey, look, we can actually reduce churn by this amount. We can actually reduce fraud by this amount. But then what's not been considered in that is, okay, well, how is production going to get funded? Who actually needs to get involved? How does production work at my enterprise? And so by default, these POCs are actually kind of in no man's land now. We're saying, how are we going to actually move that from that experiment phase to production? So one of the answers to be able to actually address this is actually from day one, understand if this is a successful experiment, if this is a successful work, how are we going to actually get it all the way to production? Starting for imagining and thinking how we're actually going to deploy this, what are the considerations around that? And so the solution for this is plan and fund deployment up front, set clear deployment criteria, bring in the stakeholders really early from IT and DevOps who are going to own the process of deployment and production, and build for repeatability. So when you start with these considerations from day one, you will actually be able to kind of work around a lot of the yellow flags and red tape that actually come out in that process. So in some cases, wrong incentives. So a lot of cases, ML efforts are actually part of an innovation mandate. They're designed to be out there, greenfield. How can we actually do something completely new? And so the goals that are set for these initiatives is learn, innovate, experiment. Instead, those goals should really be deploy, affect company metrics, and align with the business. So it's the difference between demoware and actionable, something that's integratable and usable. So one of this, things that you need to be able to answer in this is, what's the actual minimal justifiable improvement that I am willing to go through, and what the cost of that is going to be so I can actually affect the metrics. So starting from what are we trying to affect and how do we build backwards? So one of the solutions is a framework that I really like by a consultant named Ian Zhao. And so this is not mine, but I've borrowed it because I really enjoy it. Which is called the minimal justifiable improvement tree. And to actually work through this, one of the things that you can start with is actually, what's the actual objective? Are we focusing on the right problem? What are the constraints around that? What is actually good enough? So a good example of this is saying, okay, well, we believe that if we reduce, fraud, we will be saving $2 million a year by being able to move that. And we can do that within 6 months. So then there's a question, is that enough? Is that worth the investment? Well, if I need to make a $10 million investment to save $2 million, then obviously that's not the right objective. And so when we start from the improvement, which is the end goal, how are we going to affect the company metric, which again makes us thinking about production early on, then we can start going backwards and say, okay, Do we have the right business process to be able to apply this to the business? Do we actually have the right organization? Do we have the right budget? And then the right technology. And then from the right technology perspective, we can start thinking, okay, what's the data that we need? What are the models that we need? And how are we going to actually integrate that into the system? So you can see how starting from the big picture in the end and the company metric and working back will actually give us a framework of saying, okay, this is the right way to invest in it. This is how we should go and build out our machine learning processes, how we can actually apply ML to our business in a way that has a higher level of success than if we go the other way around. So then wrong teams. So in a lot of cases, we're asking data scientists who are extremely talented in data analysis and statistics to actually deal with infrastructure and to actually build infrastructure and monitor things. So if you think about it, data scientists who spend most of their time in statistical models, building out things, and now we're saying, hey, go deal with Kubernetes or go deal with large infrastructure deployment pipelines. There's just a lack of skill set here, and we're really not using the right people for the job. I usually kind of equate it to say, you have a Formula One driver and you're asking them to build a car as well or tune the engine. That's just not the right skill set here to do. So these teams lack DevOps experience. They don't actually understand what it takes to get something to production, the considerations around recovery, and they're not really partnering with the right skill set in that organization. And so one of the things that an organization needs to be able to answer is, do I have the right skill set to make my solution deployable? Again, we're starting from, we know what we want to improve on. We now have identified that we have the data and the technology, how we're going to get there. How do we have the right people who are going to help shepherd this in so that we can actually have something in production? So one of the solutions here is to create hybrid teams of engineering, data scientists, and DevOps engineers. Again, we're thinking about the entire process as one instead of different modules. Stop chasing unicorns. You're going to not, they exist. There is data scientists that have a lot of DevOps and engineering experience, but they're extremely rare and extremely rare to be able to hire. And start thinking about software and platforms that can actually enhance the data science and ML team. What are the pieces that are not core to developing in-house, and what can I actually go buy off the shelf and just help me get this process through? So again, around teams is thinking about all the people that are going to be involved. So if we think about how existing workflows and teams and processes work, how can I actually define controls for security and governance? And how can I actually provide the documentation, traceability, and integration around those things? So you can see how we will have the data scientists who are going to be involved in the training integrations, connecting the data services. You will have ML engineers who are going to actually be moving this to production, creating pipelines, monitoring the models. You'll have the developer who's actually going to be consuming these models in the application that's going to be affecting the business. And then you'll have the DevOps folks that are going to be maintaining it. And obviously the business leader who's actually cares about this intelligence going into production and actually affecting the business. So by actually aligning all the people involved at the different stages early on in the process is how we can actually move a lot faster into a production workload. Finally, lack of proper champions. So like with the deployment of any new technology, lack of champions is really a death kiss. And in some cases, we've seen this like introduction of new ideas, processes, creating a level of uncertainty and skepticism and misunderstanding. There's a fear of failure. There's also been a promise around AI and machine learning was going to affect all these businesses, but with such a high failure rate, how do we actually get executives to buy in, sponsor these projects, and actually work through? And so one of the things you want to do is really align the values. Again, go back to the business metrics, how we're going to affect them, how it's going to matter to them. Bring in those stakeholders up and down the command chain extremely early on into the process, and then ability to collaborate around goals and dictate. And then finally, the wrong technology. So there's a lack of defined technology stacks or best practices. A lot of cases, we're building one-offs that are not repeatable, they're not measurable, they're not auditable. There's proprietary locking into tooling. We're not thinking about how we access to the data, and then there's massive differences between our prod environments and our dev environments. So what we need to be able to answer is, what is the best ML architecture for my organization? Can I actually design to execute at scale, repeatably and efficiently? Can I actually build a system where all the components are tightly integrated but loosely coupled? Can I replace or upgrade technologies in my stack and data sources as my needs evolve? And can I just anticipate that this moving ecosystem is going to have always new things that need to be added to it? Can I actually quickly and efficiently add new components and rev them in a good way? So you need to remain open to integration with a variety of in-house technologies. This is an exploding space that has technologies coming at every part of the stack. And so being able to kind of replace those plug and play becomes extremely important. So now let's dive a little bit into the technical aspect of it. So if we think about systems around ML and a structure, you're going to have your data management systems, you're going to have multiple training platforms, and you want to have a standardized way of deploying, serving, and managing those things so that they're consuming applications. The standardization around deployment, the standardization around runtime is what's going to allow you to build that repeatable process to get into production that is going to be monitorable, orchestrated. You're going to be able to actually observe what's going on there, and that becomes extremely important. So you can see how you want your training systems to be able to grab data as well as your serving systems and be able to actually plug and play in this stack as much as possible. Understand that training and production are very, very different. Training is really around long compute cycles, fixed load, stateful, single user, and there's going to be multiple training platforms inside an organization. But when you want to standardize when you're actually doing serving in production, because it's around short compute bursts, elastic, stateless, and many, many, many users. So you need to be thinking about an architecture that supports that production workload. There's going to be heterogeneous tooling and dependencies, and you need to be able to plan for that. So this includes using CPUs as well as GPUs, using a number of different languages and frameworks and different versions, and how you're going to actually maintain these and actually build out, out production workloads for that. ML doesn't live in a vacuum. It's all about pipelines. So there's going to be, how do I actually pipeline my different models that I can actually replace, upgrade individually without having to build monoliths? So multiple frameworks, multiple languages, multiple teams working around that. Diversity will actually complicate auditability and governance. And this is why it's so important to have these processes and a good understanding of how we're going to do DevOps for your ML lifecycle. So how do we actually track what models are being used? Who's using them? What went wrong? How can I actually ensure security across all my global models and compliance for that? And then finally, lack of reusability slows growth. If I'm actually doing one-offs every single time I need to build a new pipeline or build a new model, what we're actually doing is slowing down the organization's ability to actually get models into production and actually affect those business metrics. At the end of the day, that's all that matters, right? We want to get to an ROI for our efforts. And so if models and assets only exist on laptops or local servers, if they're not accessible, if they're in the wrong language, or they can't be actually used by other parts of the organization, every single one of these will actually contribute to a more inefficient machine learning lifecycle. So things to actually consider when you're operationalizing ML in an enterprise: think infrastructure agnostic deployments. You might be using multiple clouds. You might be using hybrids of on-prem and cloud. You might be changing environments. Think about collaboration and pipelining. How can I actually reuse components? How I can build pipelines around this, around that. Think what the business SLAs are. So what is the performance that is needed? If I'm actually putting something on our front page or on our website, I have 7 seconds before somebody abandons that. So we need to be able to actually meet the business SLAs for our machine learning pipelines. In the case of actually regulatory compliance, this could be in financial services and life sciences and government. How do I actually make sure that I can actually meet the needs of my regulatory compliance around machine learning decision making? How do I provide governance from security, auditability, and who's calling what, when, with what data, and at what time from all the models that are being built in production and used in production? How can I actually do accounting and chargeback? This becomes extremely important when you're centralizing ML platforms. What part of the business is calling it? How much consumption are they using? What parts of the, how do we understand who's using what? And then obviously all around this, an effort around security and authentication. We are using, in a lot of cases, personally identified information to make decisions. There is, in some cases, really sensitive data going through these systems. How are we taking care of security? How are we taking care of, that? And these are all considerations that come from the DevOps world around any sort of workflow that gets into production that now machine learning needs to be able to be a part of so that we can actually see that ROI. So navigating common pitfalls don't reinvent the wheel. Focus on outcomes, not process. Don't try to be perfect. Say no to lock-in. Tools aren't solutions. And then honestly audit and revise constantly. And you want a tweet from a good friend of mine, which says like big companies should avoid building their own machine learning infrastructure. Almost every tech company I talk to is building their own custom machine learning stack and has a team that's way too excited about doing this. Again, if this is not your core value prop for your organization, this will actually be a maintenance and time sink that will not bring you value. We need to focus on how do we move those business metrics and how do we contribute to that. So if you remember anything from today, I hope you remember this slide, which is machine learning is different from production machine learning and some of the considerations around that. And I'm really happy to have chatted with you today. And if you want to check us out, what Algorithmia does is we actually built an enterprise platform for doing model deployment around connecting, loading, cataloging, versioning, and validating models in production. We provide a full life cycle for model operations that manages costs, controls of infrastructure, delivers models and services at a high velocity. And we focus a lot on this governance and security aspect of it, which is how do we actually control everything that's going on in the system so that you can actually be in compliance with your security, InfoSec, and regulatory reviewers. Thank you so much. We're going to have some time for Q&A right after this. If you want to see more about the platform, you can go check out a demo at algorithmia.com or download some of our white papers. Really appreciate your time today. Hey, everybody. Thanks for listening today. Happy to answer any live questions right now. If anybody has some questions and want to pop in, I'm happy to actually answer those. And I'll point out, we'd love to give you a demo and tell you a little bit more, and you can see on the screen some links for that. Does anybody have it? So we got a couple of questions through the Q&A part here. I think I answered one of them on the chat, but if anybody has any live ones, I'm happy to do that. Okay, great. So there's a question here, which is Algorithmia applicable to a startup looking to experiment with ML models? So yes, we actually have a Teams product. So if you go to algorithmia.com, you can sign up. This is really meant for teams that are starting their journey on machine learning. They want to deploy their first couple of models. We have a couple of pre-trained models that you can work with as well. So that would be fairly easy to do. So if you just head over to algorithmia.com, it should be really easy to figure that out. And if not, just directly reach out to me. I'd be happy to help you. That's a great question, Jasper. And so, I think at the end of the day, what we need to be thinking, so the question was how do traditional SDLC developers get along with the data engineers and data scientists? And the reality here is if we think about machine learning in production, what we're actually doing is we're actually deploying applications, right, with some sort of predictive analytics or decision-making built into it. And so our general thought and thesis here is we actually need to bring in the world of data science and machine learning into the traditional world of software development while understanding that there's some things that are different, right? At the core of it, we're dealing with probabilistic code instead of deterministic code, and that will actually have some differences that you need to take into. But at the end of the day, what's the goal, right? Everybody's goal is the same. We want to actually deploy these applications, get them into production and running them. And so if we can think about the motivations, right, from the traditional DevOps teams, which is uptime, model performance, troubleshooting, optimization, these are all things that are extremely valid also in the world of data science and machine learning. And so if we can start getting these teams to see eye to eye, which is usually they're sharing what they what they want to do in terms of, like, again, focus on that business metric at the end. We've actually seen a quite highly collaborative space. It's just a question of getting everybody talking the same language. So data scientists wants repeatability, they want speed, they want to be able to go quickly into production. The data the DevOps teams want uptime, troubleshooting, performance. And so when you can actually merge those two things together, it's a really good relationship and how you actually get these things in production. So Aaron asked, what's the cost for startups playing with the platform? So it's actually free to start. So you can actually go to algorithmia.com and there's no cost to get started in that. And so you can just go and get started on that. So Arnav Patel asked, what's the biggest challenge in building an ML model? Well, I think, there's a number of different things. I think at the core of it, I would argue that the largest challenge is really figuring out what your metric's going to be, what you're optimizing. So machine learning, as the name implies, right? It's about teaching machines how to do something at scale. And so the core concepts usually are we can do optimizations really well, we can do decision making really well. And so what are the things that we're optimizing? Are we optimizing for less fraud? Are we optimizing for less churn? Are we optimizing for increased sales? And so once we can actually define the business metric, we can actually go backwards and look at, okay, do we have the right technology? Do we have the right data? Do we have the right capacity inside our organization to be able to deliver on that? So Devin O'Hare is asking, I agree that companies should outsource ML if it's not their core business. What should a company look for in an ML partner? And so I think at the core of this is really what you're looking to do. And so in a lot of cases, nobody knows your business better than you, right? And so we have to start thinking about, okay, does it, like with any analytics workload, okay, what are we trying to do here? Are we trying to increase sales? Are we trying to decrease fraud? Are we trying to improve decision making? The things that are dealt with around actually producing the business result are best kept in house. You can always hire consultants to help you if you don't have the ability, but like nobody's going to understand the business better than you. The question is where you actually start looking for partners is in, okay, do I have the experience in DevOps? Do I have the experience in tooling? Do I have the experience in maintenance? And this is where partners, either be product partners or consulting partners, can bring a ton of value to your organization. Alternatively, if there's a partner that really understands your business, fraud, anti-money laundering, know your own customers, where you can get a lot of specialization, then you can actually bring in some consulting partners to kind of help you out with that journey. So, the answers really depends. So I apologize for being a little bit squishy on that, but it's really about driving where the core business value you're going to get out of machine learning is for your organization and being able to deploy that at scale. So there's a question from Eric Ho around large organizations are very concerned about data ownership and also integrating data with legacy systems. These are possibly key factors as to why they're building their own ML tech stacks. How do external suppliers like Algorithmia address this? That's a great question. Well, the core behind Algorithmia, at least I can speak for us, which is being an integration first partner. So by providing programmability and flexibility about using what tooling is there. Our philosophy is to come in and say, hey, you shouldn't be replacing your systems, but actually integrating into those. And so what we've done is we provided a number of APIs and abilities to integrate around that. The other thing, which is around data, which is we actually will deploy our entire platform inside an enterprise's system. So you can actually bring in the entire architecture and platform that we built, run it inside your network where you have all the complete data ownership, and then providing permissions around that entire stack. And so I would happy to expand on this, but we actually do that by bringing in the platform into you, allowing you to set up permissions around your data, and then making sure that you can integrate into your legacy systems. I think that's a core concern that you should have, which is it should be about integrate, not replace. And then the last question I see here from Aaron is around how much knowledge, ML knowledge, does one have to get value out of Algorithmia? So it really depends on what you're doing. So we have a whole bunch of pre-trained models that you can use around text analysis and things that you can just kind of use off the shelf. I would argue to get the full value of Algorithmia, you should be building your own models and deploying them. I mean, at the core of it, that's what the platform's for. But if you're just trying to get started with some image recognition, some NLP tasks, some things, there's a lot of off-the-shelf stuff that you can just start from directly on algorithmia.com. Great. Well, it's been an absolute pleasure talking to all of you. If there's anything else I can do, I am DOPPENHE on Twitter. You feel free to tweet at me. I'm happy to answer more questions. Please do check us out at algorithmia.com. And I hope you have a fantastic rest of this conference today. Have a great one, and thank you very much for your time.